Alright, now that we got all our inside section done, we're going to go ahead and install our outside panel as soon as I turn my air on.
Welcome to D.I.Y. Automotive School with my friend Pete and Minnie, the body shop girl. It's everything you need to know about cars and more.
I'm going to go ahead and clean all the edges of my panel on the outside, and I got to clean the edge on the inner fender lip here, and then I also got to drill some holes for our spot welds on the fender lip. Now, I don't know if you noticed when I did the flange tool, I went kind of in a round circle right here because I couldn't get a square on there. So what I did is I rounded off the edge on the corner here on our replacement panel. That way it'll go inside there instead of overhang. To do to pop my holes in our fender lip right here is I'm going to use my flange tool again. Now on the other side of the flange tool there's a punch, so we're going to go ahead and punch our holes out using that tool for our spot welds. Very easy and simple situation. You just stick it on here like this, and I don't know if this is actually okay. I don't know if this is even going to work. I better even see about that. Hang on one second. Alright, yeah, it'll work. Okay. So if you get a good flange tool, it should have a punch on the other end, and what that's for, those are for spot welds. And you just basically stick it on here like this, and then start punching away. Now, the trick to using the punch tool is that you have it basically upside down because the little punches come out the bottom there. So, yeah, remember that. Yeah, the last two I did didn't punch out. Okay. There's one. I said that we were going to be butt welding all this over here. Well, what I'm going to do is I am going to go ahead and install this first. Get my panel back out because it's kind of in there. So what I'll do is I'll go ahead and put one screw on here, and then I'm going to go ahead and tack weld this on, because when I put these other screws in, that's going to actually get us out of alignment. And we want to stay in alignment all the way around. So remember the screw holes when we first put this on? We want to go ahead and line them screw holes back up. We want to bring that back together right where we left off, just like that. While I got it screwed on here with everything lined up, I want to take my pencil and I want to draw a line right here. because I have a feeling that this is actually overlapping. So let's double check that just to make sure. And if it is, we're going to go ahead and trim it up. And I will let you know that, yes, it does look like it's overlapping. I will let you know when you get toward the end of this type of a job, like what we're doing here, it really starts to get to be frustrating. All I'm thinking about is finishing it out and getting it done. So you got tools everywhere and you're frustrated and you just want to get it done. You got half your toolbox on the floor, half is on the roll around chair, and yeah. So bear with me, we're going to get her done. This lip here is actually a little bigger. I'm going to go ahead and cut it because I don't want it to overlap. I either want it on the flange or I want to butt weld it. Because if we have the metal overlapping on top of each other, like this, let's say this is this panel, and then the other panel, and then it's overlapping like that, okay? So this is this panel, and then the panel goes on, or whatever, yeah, like that. What happens is you got that much thickness plus the weld on top of the quarter panel, and we don't want that. Because then we got to take our hammer and dolly and we got to hammer that in to fill it with Bondo, and that's just going to create more of a problem. Now we will have to do some minor body work in this area, but we're trying to keep it either using the flange where it's all the way across and the metal's flush, or we're going to butt weld it like this. All right, you see what I'm saying? So it's very important to try to keep that metal either in the flange area or into a butted situation where everything will line up. So let's go ahead and put our panel on now. If I can get a hold of that screw. Make sure the hoses are out of the way and all the welding equipment, and then you should be able to go. Is anybody out there left-handed that's watching this? Does anybody out there realize that the world revolves around right-handers, and even a tool like this revolves around a right hand, and I'm going to show you why. When you take the drill bit, when you want to go in reverse, you push this button here, which would make it in reverse. But most people don't use the reverse. 90% of the time you're using the forward, okay? So when you're holding it in your right hand, your finger, your trigger finger, automatically keeps pressure on the forward position. So when you're left-handed, you got to really be careful, and you see what I'm saying? Because if not, you're gonna push it, and then all of a sudden now we're on reverse when we want to be on forward with your trigger finger. That's just one example of being left-handed, is that it kind of sucks when it comes to shit like this. And I can show you other examples of tools, but yeah, you get the idea. So that's just a tech tip from a left-handed guy to another. All right, before we screw in, I got one screw holding this in. Before I screw anything else in, I want to go ahead and get all this reveal here, all this composite situation right here lined up so I can get this tacked on and it'll line up. Because once I start putting these other screws in, if I don't do that, we're going to lose this situation here. Does that make any sense? I hope it does, because I'm going to keep on going. And you can basically see what I'm talking about. You got this line here, you got this line here, and then of course you got this curve. When I put other screws in it, as you can see, the screws will push it in like that by the time we're done screwing it down. So we want to keep it nice and level all the way around. We want to line that up just like that. I'm holding it with my hand, as you can see. And I should have started, there it is, right there. Okay. Then we want to get a couple right here. And then, since this is a butt weld right here, we're going to go ahead and get a couple right here as well. And I see where our panel's just sticking out just a hair, so I'm going to go ahead and push that in using my pry bar. Just like that. Okay, so all of our corner here is now spot welded. We're going to go ahead and move down the line and screw our panel back in to where we had it before, and then we'll start installing our panel. Alright, now we're ready to go ahead and start spot welding it all the way around, and then we can remove our screws and spot weld them holes up. We'll get this spot welded inside here next, and then we'll go back and stitch weld that back and forth, up and down, until that's done. Now, this is where you want to take your time. You don't want to get in a hurry, because getting in a hurry on this will warp our panel. We want least warpage as possible. So let's go ahead and start stitching it on there. I'm sorry, we're not going to stitch it yet. We're going to spot weld it, and we're just going to put very small spot welds like we did over here, so we don't create a lot of heat. And here's a little tech tip for you. Even though we got good lighting behind us, I'm going to turn one of those lights off because it's really bright. We got our door shut today. It's raining out and the wind's blowing. There we go. Okay, so even though we got good light behind us where we can see everything, it's always a good idea to have a little magnetic flashlight like this one here, and then you stick it like that, and then you can really see good when you're welding. Even when you got a helmet, a futuristic helmet like what I'm wearing, where it's light and it's an auto dark helmet, having this really helps out a lot. Alright, so our panel is now welded on to the car, spot welded. And what we'll do now is we'll remove the screws and fill those holes. Alright, now that we got it all done here, it's all spot welded on, it's ready to go ahead and finish out. This is a trick that I'm going to show you to help keep the warpage down. Now, we are going to weld this all the way across using our MIG welder, but every time that we do a stitch weld, I'm going to start over here, and then I'll come over here, and then I'll hit it in the middle, and I'll hit it in the middle, and I'm just going to randomly go back and forth till all this is filled up. And the way that I'm going to do that, I'm going to go in between each spot weld that I did. All right. So what we're going to do as we do this, I'm going to show you this little trick here, and this actually works and keeps the warpage down. Is after every weld, I got me a bucket of water down here. You can see that right there. And what I do is I take an old sponge and I soak the sponge in water, and then I hit the weld with some water, and it cools it down very quickly. So that's what we're going to be doing. This is the way that I do it. I don't know anybody else that does it that way. I'm sure there's somebody out there that does. But yeah, let's go ahead and get this started and get this done. We finally got it welded in, and it came out really, really nice. I went ahead and used my sponge with the water on it, and I just did a little bit at a time. One weld here, over here, back here, you know, just randomly doing it and connecting my stitches together as I was going. I see a small spot right here. It looks like a screw hole. I didn't get it. Let me get that. You see what happens? You see the situation. You got to make sure that you get it all done the right way. All right, so now that we got that done, let's take a closer look at it, and you're going to see that the warpage on this was very, very minimal. So if you look at the weld on that, you can see it's nice and straight. We don't have a lot of warpage going on. Everything welded up good by using our sponge water trick. All right, and taking our time and welding it. I still got to weld the bottom of that. I'm not going to do that right now because our floor's wet, so I'll come back later and zap all that together. But our quarter panel replacement panel is done. There's only one other thing we got to do, and that's grind our welds down. And this is where most people run into the biggest problem, is grinding the welds down. Because when you're grinding those welds, you're creating a lot of heat. And that's what we're trying to avoid, is creating that heat. I want to show you a little something here. I want you to pay attention. I want you to look at this grinding disc that I got. All right, you can see how thick it is. And this is your common everyday grinding disc that you would use for metal. Okay? And a lot of people are very misconfused about how to use this grinding disc. You do not use this surface here, you use this surface here. So if you are using a grinding disc such as this is the edge that you're going to want to use to grind those welds down, not this edge right here. Now, this particular style grinding disc causes a lot of extreme heat. It causes enough heat that if you stick it on there long enough, it will turn orange. It will literally start melting. So what we're going to do to compensate for that is we are going to use a flapper disc. Flapper discs don't create as much heat. They're a lot faster, more efficient, and the consistency of your grind will be a lot nicer. This is basically what you're going to want to use. Using a flapper disc, believe it or not, air is created between these flaps, and it's literally cooling the disc itself down, unlike our solid carbon grinding disc that we have here that is just solid, and the only thing that's being created by that is heat. So what I'm going to do is I'm basically, if we look right here, there's my bucket, I still got it here. I'm going to take my sponge, all right, and you can see how I've used it, all right. It's been used and abused. So we're going to take our sponge and we're going to go ahead and use the same method on our grinding as we did our welding. This is where a lot of people mess up. They get real nice welds going, no warpage, and then when they go to grind it, they don't use the sponge to cool the metal down, and the next thing you know, this thing's all warped and ugly. And that's what we're trying to avoid here. So let's go ahead and do a little section right here, and I'm going to show you what we're talking about. We're just going to cool it down. You can see the steam coming off it, how much heat we've created. And what this is doing by using the water is pulling it back out, so it's stretching the metal. See what we got there? And now we got a nice weld that we'll be able to fill in. It's all about keeping your metal cool and working your metal like you should do. Now we're not TIG welding here, we're MIG welding. If we were TIG welding, we wouldn't have to worry about all this. But you know, we're doing this at home and we're not paying some guy out there in a shop $350 an hour to put a panel in like this with a TIG welder. And then once we get it ground down to that perfection, what I usually do to finesse the welds and to make sure that we got a nice, good, level situation going on is I will take my cutting wheel. This is our cutting wheel right here. I'm going to take the cutting wheel and I'm just going to hit the welds themselves. And then to give us a nice finish fit, I'm going to take my roll-lock grinder right here, and I'm going to take a 36 grit pad. And on the electric grinder, I was actually using a 40 grit pad. I like to use 36 grit, but they didn't have any. So that's just a little reference there for you. That was a 40 grit pad, cutting wheel. Then we go to the 36. Now, what we've done is we have finished installing our quarter panel patch, and it is now ready for body filler. One more thing I want to do, I'm going to take this grinder, and you can kind of see some little black stuff. I'm just going to use the edge of this grinder to clean that out. And we are now ready to do our body filler and finish this out. A job that took quite a while to do, but came out professional, came out nice, and guess what? We did it at home in our garage, and we didn't pay the big boys to do it for us. So that's basically how it's done. Practice does make perfect, especially with your welding. I did find out one thing. My Miller-Matic 251 is 20 years old, and I just purchased a brand new welder, which you can see right there, and that technology in that little welder right there, I'm not going to go into it, you'll have to watch the video on it, but the technology in that welder right there actually outbeats the technology of this welder. So size doesn't matter when it comes to welders, because what you're doing and how you do it is what really matters. This is Pete, my friend Pete, your friend Pete, showing you how to fix that rust, replace panels, and make panels all in one slew right here at DIY Auto School. I believe the owner of this Camaro is going to be a happy guy, and I think he's going to love the job that we're doing for him. Take it easy. We'll see you later. And make sure to subscribe, comment, and like this video and all my other videos. If you're not a subscriber on my channel, I'm asking you to subscribe. Subscriptions on YouTube for a YouTuber like me really helps out and goes a long way as far as getting my YouTube channel up in the ranks. So I really need those subscriptions, and I'd like to get as many subscribers as possible. If I'm helping you, which I know I am, then you should be helping me, because that's all I ask out of anybody. I don't ever ask for anything, and I don't ever expect anything, because the only thing that I want to see is you doing it right. We'll see you later.
Thanks for watching D.I.Y. Automotive School. Classes don't stop till you know everything.